Hello everyone, this is the next topic in Unit 2, that is bias variance trade-off. In a previous video also I have explained this bias variance trade-off, but another example or another definition for this is, while building the machine learning model, it is really important to take care of bias and variance in order to avoid overfitting and underfitting the model. This bias variance trade-off is used to overcome by underfitting and overfitting problems. Okay, if the model is very simple with fewer parameters, it may have low variance and high bias, whereas if the model has large number of parameters, it will have high variance and low bias. Okay, so it is required to make a balance between the bias and variance errors, and this balance between the bias error and variance error is known as the bias variance trade-off. Okay, why we are using this bias variance trade-off? Mainly to make a balance between bias and variance errors. Okay, to balance these both the errors, we are using bias variance trade-off. Okay, next, optimism of the training error rate. This is the next topic in bias variance trade-off. Next topic. So what is happening here? Optimism of the training error rate. The term optimism of the training error rate is often used in the context of model performance evaluation, particularly when assessing the performance of a predictive model on the training data. This optimism of the training error rate is used to find the error rate of a particular training data set. Okay, till now we have learned that where will be the errors come and how it will be, and where is overfitting and underfitting is happening, and what is the error rate when we are doing with the training data sets. Okay, the optimism refers to the potential difference between the model performance on the training data and its expected performance on new or unseen data. Okay, this optimism of the training error rate is used to perform a potential difference between the training data and the expected performance on the new or unseen data. Okay, in the context of model evaluation, the optimism of the training error rate is calculated as the difference between the model performance on the training data and its performance on the separate validation or test data. Okay, let's see here formula, then you can understand easily. The optimism can be expressed as optimism is equals to performance on training data minus performance and validation or test data. If we perform this formula, you can get optimism, means what is the error rate. We can easily find the error rate of a training data sets. Okay, a positive optimum suggests that model may be overfitting the training data. Capturing noise or specific patterns do not generalize well. Positive one will suggest the model. This will be the problems if the positive answer will be happen. On the other hand, a negative or a low optimism indicates that the model is performing consistently on both the training and validation or test data sets, suggesting better generalization. Okay, in positive, if we get a positive answer, then it may be leads to a overfitting the training data. If we get a negative or low optimism answer, the model is performing consistently on both the training and validation. So what you should get if you perform this formula, you should get always a negative value. Okay, model evaluation techniques such as cross validation are commonly used to estimate the optimism and access model ability to generalize. Remember this cross validation, that is also a topic in Unit 2. In later videos I will explain this. Okay, next, see here we have an example. I am considering here mean square error optimism. You can use any optimism techniques to find the error rate. Okay, the optimism of the error rate is often calculated in the context of a performance metric like mean squared error for regression problems or accuracy for classification problems. Okay, let us see this example. Don't feel that it is lengthy. If you understand, it will become easy. Okay, if they ask for 5 marks, or if we ask for more than 5 marks, it is very easy to write it. Okay, don't feel that it is very lengthy or very high points here. Okay, don't feel that. See here, training phase. First we should do a training phase. During the training phase, you train a regression model on a data set and calculate the mean squared error. Firstly, you should suppose you think that mean squared error training you got 50. Okay, you should not do that mean squared error optimism here. Just you can assume. Okay, this is mean squared error optimism is not in our subject. I am explaining just to assume that. Okay, when you are doing a training example, you got answer 50 in training phase. In test phase, we got MSC test is equals to 70. Okay, next. This is a test data set and this is a training data set, upper one. This is a test data set. Okay. Next, calculate the optimism using the formula. What is the formula of our optimism? Training data sets minus test data sets. Okay. Here I kept here. See, MSC training minus MSC test. What will get? 50 minus 70 is equals to minus 20. We got minus 20. It means here I told you. On the other hand, again negative or a low optimism indicates that the model is performing consistently on the both training and validation sets, suggesting best generalization. It means we got minus 20. It means it is correct. Okay. If we get positive, it is not correct. It leads to overfitting or underfitting. Okay. Now you understood about what is the optimization of the error rate, training error rate. It means it is suggesting you what is the answers, what are the we are getting the solutions. Okay. Next, a negative optimism of minus 20 suggests that model performance on the test data set is worse. Means it is high MNC than on the training data sets. This could indicate potential overfitting and adjustment model may be needed for the better generalization. Okay.